All right, everybody, thanks for coming to my talk. I'm really excited to talk to you today about how I'm using our awesome language to basically fight human trafficking. So welcome to Rust Against the Odds. All right, so for who I am, I'm Brooke Dewson, but I go by Going for Brooke because the last name's kind of hard to spell, which is something you might be able to relate to. I've got Twitter, I've got Blue Sky, I've got Mastodon, and there's also a Discord channel too if you want to talk more about this talk while it's running or afterward. Same title in the Discord for the conference. Now, what we do at Trafficking Free Tomorrow is that we make free software built purely in Rust for law enforcement to fight human trafficking. We believe that the solution to working on this problem is breaking up these networks and finding ways to make their products more expensive. From the criminal mastermind's point of view, this is just a business and they're selling things which are legitimate, which are people. So if we can raise the cost of selling people, then they'll find something else to do. A lot of this comes down to getting evidence down the last mile, because before things become evidence, they start off as discovery. And discovery is kind of like the stuff that's like, you found it, and maybe, at a crime scene or something, if it was a physical object, it goes into a bag, it's tagged. And then there's all of this like chain of custody stuff that has to happen, where every time it changes hands, it has to be re-inventoried and rehashed. So we know that where it came from and where it's going to, and every step in between is verified. So everything that was in that directory has the same hash, has the same place, everything is still there. Because once you get to court, the defense is going to tear you apart with case law like Zubalake v. Warburg, where they're much more well-defended, they're much more well-funded because the traffickers tend to have money from their illicit activities. And there's not really much of a way to fight this other than to have some really expensive software that's kind of out of reach for a lot of these places on the front lines of the trafficking thing. The people who are fighting this are going to be the law enforcement agencies who are very small. They don't have a lot of technical talent. They don't really have a huge budget, and we try to find a way to deliver to those folks because they're on the front lines of these trafficking pieces. Not just the national things, not the big people with the giant budgets, but people who can't afford things like this for-profit forensic products. Sometimes they'll be up to like $250,000 just for buying the basic product and getting started. So we want to make something that's good, and also we have a pretty low margin for error on this because these things have to be auditable and they have to be available for forensic examiners to go through and kind of prove that their tool works every year. So once we come over to the users, these are people who are non-technical, as I said. They tend to be very fond of paper. They tend to be lawyers. They tend to be folks who kind of, they're not really, all the way up on technology. They might have the basic, kind of Wikipedia summary, but as they're actually using the stuff, they need something that's very simple and that kind of, straight to the point and that explains itself. It also has to be consistent across platforms with edits, and it has to have pretty much rare updates because we're deploying to places where they don't update too often. There aren't very many dependencies. It's a very locked down kind of enterprise environment. So it's kind of a hostile place to be coding in the first place. The way that I got into this was that I was working on this, had a bad experience in college, and I was really angry after that experience. So I started volunteering with law enforcement. And there I found out that a lot of the forensic tools that they had were really not good. They didn't serve these needs. They didn't meet this user, and the ones that were out there were really, really expensive. So I started writing Python scripts to make that work. And that worked well as long as it stayed on my machine, but actually deploying that to people or attacking a global problem with a global solution was not going to be available. So around 2018, 2019, I got into Rust because I was a way to deploy to multiple platforms and have basically no performance ceiling. Now, some of you might be thinking, what about server-side? Why don't you just make a server-side application? Why don't you have a web app like every other normal person in the world? Or maybe like a Z shell script or something? But getting software into these environments is really difficult. Opening ports, getting things approved, setting up servers. Earlier versions of this application and 5 or 6 others that TFT makes were really based on a Kubernetes style, very traditional like multi-server architecture thing, not necessarily for going faster, but for strapping together more junky servers and trying to squeeze as much performance out of them as possible. But actually getting deployment to that, deploying on their servers, deploying on their hardware, dealing with all of that, it just basically never happens. So getting away from GovCloud, getting away from heterogeneous deployment environments, getting away from the server, what else do we have? We have a thin client. And this is where the talk gets a little bit cursed. Because we got this guy to work with. We got a little Celeron. He's got a Pentium i3 in there, maybe an i5. He's got about 2 gigahertz on the cores. Maybe we have 4 gigs of RAM, but they want the big package from Dell. They might have gotten 8 gigs of RAM. And we've got eMMC for flash. Sometimes there are spinning platters, though, so I'm a little bit sketched out by doing too much I/O, but I really wanted to have a way to deploy to this lockdown legacy environment in a way that was reliable, in a way that was reproducible. And Rust was the way to do that, because Rust gives us the options for no performance ceiling. No matter what, it might not be fast today, but it can be fast tomorrow. My favorite ticket that I get from users that I haven't gotten yet, please tell me to do this, is to make it go faster, because it can always be faster. There's no problems with like dead on arrival shipments. If it compiles, it works. It works on my machine. It works on Mac OS native for Apple Silicon. It works on Mac OS x86. It works on Linux. It works on Windows. It runs everywhere. The same way I can ship it, walk away, know that a new feature or a new bug fix works everywhere, except for Windows paths, cough, cough, but that's a different story. Other benefits here is that we have the White House and the previous administration saying that Rust is awesome, basically, saying that we should use memory-safe languages. Can't think of too many of those other around that are as good as Rust, just my opinion. And we also have NIST saying the same thing, saying that we should start doing full adoptions of Rust in these languages from the very beginning. It should be written architecturally from the ground up. Personally, for why I made a Rust app was like, this is helpful kind of for the sales pitch or for by telling people why you should use my free software in your department. But at the end of the day, a lot of it was just convenience for developer ergonomics. I'm just one person, and being able to ship to those things and make this work from a GUI at the top all the way down to what we'll see later with the data storage layer and concurrency primitives and everything, Rust is the only real way to do that. So I want to introduce formally FolSum, which is a folder summarizer. And this is basically what you could do with the Z shell script or a bash script, where you recursively go through a directory and generate hashes, your MD5s, your SHA-1s, your SHA-256s, and check to make sure that all the contents that were there last time are still there this time. Now, what does this thing do? Oops. Now, what does this thing do? It checks that the files exist in the same location, that they haven't been tampered with, that the hash hasn't changed. And if the hash has changed, we can tell what happened. We can tell if it moved, if it changed, if it was deleted, if it wasn't there anymore. And that makes a manifest that we can move from place to place. And because it's Rust, because the executable is so small, this isn't just for prosecution, this also goes for defense as well. Whenever you make evidence, whenever you make discovery, and you ship it to a public defender, you can ship this executable with it, so they have the way to open the file along with it. No one can really ship EXEs and emails anymore. Those good days are long over, but you could, and I really like the idea of that. So we'll move to a quick little video demo. I have a little MP4. Or I have one. No? All right. I can show you a video demo at the end if we have time. Getting over to system constraints, there's some surprising advantages once you just reduce yourself to a thin client. Keeping it local keeps it simple. There's no network problems. There's no update issues. I don't really have to deal with multiple browsers, multiple screen sizes on browsers. I don't have to deal with the whole React style update piece. We can just all keep this very, very simple and very, very portable. It ships as an entire binary with no dependencies. And because there's no RESTful API, only one interface really needs to change. And that means that we can deploy to all the things. It's cross-platform. On Mac OS, like I said, we have for both chip architectures, universal binary that's signed and notarized, and NPX increases the memory maybe by about 50% or so, but since we're still around maybe 50 or 60 megabytes total whenever we're running, it doesn't increase it that much. And that means that the whole program lives in memory for the whole time that it's running. Rust features in action. There's no splash screen. Usually whenever you get a forensic application, they're just starting to move to web apps now, but you'll get this big splash screen. So this monolithic Java application has a lot of heavy lifting. So it'll be like, hello, you know, this forensic thing. And you're sitting there staring at this loading screen for a while it like initializes its database, whatever it's doing in the background. With Rust, it's fast, so you click it and it opens as soon as you release your left click button, which is neat. It creates a lot of user trust, as we'll see with the GUI. Inside, the actual goody, really good pieces that I know you want to hear for. With concurrency primitives, starting off with this, I didn't really know. I've had no formal training in this. This was my first introduction to any kind of real-world multiprocessing. I have Maribos's book on Rust async to thank for that, and it's Rust Atomics and Locks, one with the bear on it from O'Reilly. Yeah, it's good stuff. That's how I learned concurrency, and I did that with Rust. So my implementation is a little bit cursed, but you see that for most functions, we have a whole bunch of arcs that come in, and we clone those immediately, and we access the same pieces. That's kind of cool, but deadlocks suck. Solving those is something that LLMs still haven't caught up with, and whenever you get one, it's very, very bad. Because there's no database layer, so to speak. It actually shares it with the GUI, and either it's being processed on and it's working, or it's being released and it's waiting. But that means that whenever I'm working with mutaces, I just end up kind of compulsively dropping the lock everywhere I go to make sure I don't get a deadlock. Not the most graceful thing, and at the end of the day, this is only a way to get started. This was a great way to get me to the MVP, to get a deployment, to kind of put in front of people and start riffing on the GUI and the UX and how they're actually going to use it in their workflow. Because at the end of the day, moving to channels, this got, it's not currently deployed right now, but it's about a 250% increase. And I don't know why more people aren't like chanting the beauty and the loveliness of channels. They're so simple, they're so fun. Everything gets wrapped in an enum, which kind of works off the message passing of the structures, which is what I really like from an Elm-like language. Say with something like ICE or something, but it's much more usable. And even for error propagation, instead of having to push that through async, because low-key, there's no async in this very high I/O program right now, kind of sucks, but being able to wrap that in just an error subclass of the enum and to push that back up out of that function and push it through that channel, and then have a match on the other end to decide what we're going to do with it was really awesome. Very simple, easy to reason about, and nice whenever you have to like overhaul the GUI like every 2 or 3 weeks with rapid iteration stuff. All right, with Rust, the batteries are included. Like I said, there's no async code. There was no Tokyo even. At the time, that kind of became like an in vogue dependency to add. I might need it at some point, but I kind of challenged myself to be like, okay, how far can I get with the standard library? Because at one point in the future, I'm going to have to speak for every single dependency that I have in here. And if something becomes unmaintained, if something has a security issue, well, they might just dump the whole program, or they might access it from the image for their drives. So right now, other than the standard library, there's only 5 or 6 dependencies, most of which have to do with persistence and the GUI stuff, because that's stuff that I really don't want to have to work on myself. So for that, we use eGUI. It's nice. It's immediate mode, which means that it's a slightly cursed, but it redraws the screen every time it runs. It's constantly sitting there going through redrawing, but that means that we get to escape the whole React paradigm of currently updating pieces or using, is it composition? Is it this? Are there hooks or anything? No, you always see the state currently with what's going on. It's always showing you to that, so it's very easy to work on, very easy to debug. Other things is that eGUI means that we have no other dependencies for GUI stuff. A lot of times it's like, oh, you just need to download a thing for like the Qt library or for this or a C++ redistributable. If that's not already on the machine, then I'm just not going to deploy there. There's no way they're going to be able to update that. It needs to come all bundled together, and that's what Rust lets me do. As a slight kind of downside, it might be a bit CPU heavy. If you're looking at it, since it's doing all this redrawing over and over and over again, it does pull a lot more CPU than other programs might. But if you compare that to a browser, which kind of goes back to our sad bear server-side implementation, it's about the same anyway. And the author, Underrepresented, has even posted about how the internals aren't even optimized yet, and it still has pretty good performance, which is more than good enough for me. On the other hand, we don't have the cool layout functions. We don't have any, well, there are a few animations like button click things, but nothing like too fancy or over the top. But that turns out to be a feature with my users. They thought that was really awesome, honestly. Runners up, I know that we have some people in the house from Dioxis. I really loved your stuff, but at the time I couldn't get it to work yet. It might be good now, but this was like 8 months ago, and I know that a lot has changed on that project. MakePad and Slint were kind of interesting. MakePad, it seems like it wasn't quite production ready, and for Slint, it had more of an embedded focus. Iced was interesting, and that was kind of an Elm-style way of doing GUIs I thought could be easier, kind of an alternative to the React model or model view update. But at the end of the day, it's not maintained, so I couldn't get very far. Like I had my initial calculator example, and getting past that, the docs and everything, getting it cut out wasn't really going there. And I'm really excited to see where Xylem is going as well. I think that's going to be an awesome GUI toolkit in the future for a retained mode GUI. For the UX, we keep it simple. In the GUI, this is basically the whole left panel. I kind of talk about docs or GUI as docs is kind of my little meme thing that I'm starting with this, where the documentation is just like one giant page that happens to have some buttons talking about what you can do. A lot of this is fairly boring for people who aren't in the legal tech area, but for domain-specific experts, just seeing this laid out like this with only 4 buttons, reducing everything to 4 buttons, and dark mode, because we got to have that, really makes them happy. Whenever they see this, they're like, wow, this is kind of awesome, which is not what I expected, because whenever I look at that GUI, I'm like, yikes, what went on here? But as it turns out, I talked to a user, they're like, about the GUI, and they're like, I know, go back. And they're like, you did a really good job. I'm like, no, you don't have to be nice. Like, tell me what's wrong. Is it the dark mode? Is it the thing? And they're like, no, there's this one thing. And it's like, no, please tell me. But all that to say that they actually loved it. It was something that had a really positive reception. And they're like, why isn't more software written like this? Which is wild, but yeah, it went over well. Going very simple not only made it easy for me, but made it easy for my users. And I was planning on this being the initial alpha ship, but now I'm kind of reluctant to change it. Oops. Getting into testing, because in Rust, it's very easy for us to write unit tests. We generally have 1 unit test for every module. Usually it goes after the public function, and it'll do something very basic like, does this file exist, does it not exist? Starting to do these early on was really nice, and using Nextest to run it super fast was really awesome. It's definitely worth it. You can just install the CLI. You don't need to do anything else. That was pretty sick for making sure that whenever I add something, nothing breaks. As well as in benchmarking. Criterion's awesome, and just like with having 1 very basic unit test for every module, having 1 really early benchmark. I think our current benchmark targets about a directory with about 10,000 and then 100,000 files in it. Our actual target is maybe around 250, 400. That's what people are doing manually right now to hash each one of these every time it changes hands. So being able to do that and get these sick little flame graphs over here was really helpful for seeing if it gets measured, it gets managed, and I always challenge myself to measure something before I increase the performance of it. Doing that and kind of seeing where things are actually going kind of informs decisions. Do we want to actually move to channels? Do we want to make a whole new other piece that works with something like social media? Are there other things that I can do? And since I'm just one person, how can I best spend my time on this project? And this makes that happen, which is very nice, especially when you start adding different hashes and stuff, and all the multi-threading just goes crazy, and it gets wild. And yeah, for the reception, a lot of it was, this is free, because I set out to build a 4-cylinder, just very basic Jeep Corolla, just something almost painfully awful, painfully simple, but I'm giving it to people, and they're like, wow, this is great. Why don't we have more software built this way? And I think a lot of this comes down to the trend in the industry to make things that have more and more features, more and more bloat. It's all a web app. It has a lot of sync and state issues when anytime we go to a website now, we're used to clicking something and not quite trusting what's on the page. So for a lot of people, especially people who like paper, this is a breath of fresh air. And they're like, yeah, this is a Lamborghini. This is one of the favorite parts of my day, or favorite parts of my workflow now for doing this. Now, from the beginning, I wish that I knew a few things. I wish I knew that Rust actually makes weak machines viable. I didn't have to do that whole Kubernetes piece. I didn't have to do, instead of having this one giant monolithic application like all the big boys had that was doing all of the work in one place, I could have just had 5 or 6, a constellation, I call it, of 5 or 6 smaller ones, which can be updated and deployed independently. That's really awesome. GitHub Actions. Yeah, I got it working. It did everything at one point. It had some great PRs, and I think it's good for open source folks. But if it's just you, it's probably, you can leave it till later. Like build the dump script locally. Don't even put it in the repo. You don't have to tell anyone about it. Just make that happen and get it out there and get to actions later whenever you actually have people working with you. I kind of wasted a lot of time there, but there's a good blog post on it. Avoid the advanced language features. There's an embarrassing amount of nasty for loops in here and chunks of code where every time I look at it, I'm like, wow, I'm going to change that today and I'm going to change that tomorrow. But backing off on that, just getting something out is actually pretty cool. And especially with my whole philosophy of measuring first and then managing it, I intentionally write poor code in the beginning so I can have the fun later of optimizing it. And that feels a lot better than be able to go through and be like, haha, I wrote a dot map just perfectly this time, and this time, everything's fine, the closure's perfect. And then 10 minutes later, you're deleting all of it because, the structure of the code changed. That just sucks. So instead of that, having things going back with entire feature branches dedicated just to increasing performance and using those more advanced language features. And also avoiding in vogue dependencies. I was really surprised at how far standard library could get me with how cool everything else was at the time, and I'm quite pleased with what already exists in the language, which you guys already built for me to use and make this possible. Because honestly, without Rust, this would not be possible, and I'd probably still be messing around with C++ or C# or who knows what else, and trying to get it to deploy to 6 or 7 different platforms. In the future, like I said, channels are dope. Getting all of those moved over, not only for this, but it's other sister programs that have spawned off of this. Because at the end of the day, low-key, I only built this in order to build out the packaging and all of the shipping, the CI/CD, the wrapping, how do I get the website up, how do I do the downloads, how do I actually deploy, and this is just the beginning of a whole other network of anti-human trafficking programs, kind of built off the Corolla model of things that we're going to keep shipping out. RipGrep has some really nice directory traversal in it. I'd like to kind of steal that or borrow it or however else. Maybe actually add some async. That'd be kind of nice, right? Like we're touching the disk more than most programs are. I think it'd probably go a lot faster if I actually jumped on that. Staying away from that, I think, helped me iterate a lot faster because it was really easy to debug. It was really easy to propagate errors for, and I didn't have to deal with anything. And I was surprised that it went as fast as it did for something where I'm literally, hashing every file in the directory. It does okay for just being synchronous. And what's even scarier, too, is that it's synchronous with the GUI on different threads. So if something messes up and something deadlocks, you see it. Everything just freezes, it breaks, it crashes, it burns, everyone cries. It's awful. But it's informatively awful, and I like that. Something else is truthful progress bars. Users love progress bars. That'd be so cool if you could have a hash in progress, on a thing. And part of the GUI is that you can look at it, you can see exactly what's going on. Wouldn't it be wonderful to have a progress bar on what's happening and have it actually show progress, have it actually be linked to how many bytes are being read out of that file? I think that would be sick. Network drive protections. Because of the nature of this program, I think that if you have this at a decently large agency, everyone comes in at 9 a.m., they start up their box, they hit go on this program, I think it's going to kill your NAS. Just saying. So if I could find some way to check out the average latency coming off of a drive and refuse or give a little warning or something, because I don't want to get angry calls from IT your program keeps killing our drive because Rust is just too fast for them. It's not my problem. Adding more hashes. Right now we're mostly MD5s, but SHA-1 and 256, SHA-1 and SHA-256 are big. There's a couple of rolling hash algos I like to get in there. And a crash reporter. For the most part, I don't get stats unless they send it to me. I don't get to do update notifications. I don't get any access inside of this network. But it would be nice if it just dumped it to a text file or opened it in their email. And it's hey, email me the stuff, because honestly, after all the Jira boards and GitHub action boards and everything, we're back to email again for feature requests and fixes, which isn't great, but we're working on that. Special thanks. Thank you everyone for making Rust. Thanks for making this happen. It took a while to kind of like learn it. I think from 2018 to 2020, it was just kind of getting in with the borrow checker and everything. But once I had that down, it's been awesome for main business stuff. It's been awesome to make this happen. For crates, Ernerfelt with eGUI, thank you for making a GUI thing that I could actually use. I think most of this project I spent just trying out different GUI crates and also trying to get the deployments to work and have it all be scripted and automatic. So making that happen was awesome. Mary Boss's book, Rust Atomics and Locks, as I mentioned, that was so awesome for teaching me concurrency and just Rust in general. And then I know Luke is here somewhere, his Zero to Production Rust. Even though this is a back-end focused book, I thought this was really awesome for an idea of what a mature deployment pipeline looked like. Because I'm used to being like the guy over in the corner of the office that no one likes, who's like, I do the deployments, and you're supposed to go over to this like Igor person and kind of beg them to add your dependency. So seeing what that's supposed to look like in a professional way was extremely helpful for that. Let's see, now with 14 minutes left, we're gonna move into Q&A if you'd like to know more. Let's see, it's not on here, but we also have the extended Q&A or offline Q&A in the Discord channel. I believe for this one it's called Rust Against the Odds. It's got a little number 1 next to it, so I'll be on there if you want to talk to me or ask questions about the work that we do, Trafficking Free Tomorrow, why does some of my code look like it's not great, or anything else. All right, and that's it. You're all bristling with deep coding questions about concurrency.
The microphones are in the aisles.
Oh, okay. Already distributed.
If you want to come up and ask a question, the microphones are in the aisles, and then you just kind of perform a cue and ask a question in sequence.
All right, they're saying like.
We'll start over there.
Okay, cool.
Cool.
Yeah, I just, you talked a lot about performance. Could you expand a little bit on why that's important? Are these like evidence folders having hundreds, thousands, tens of thousands of files? If you could expand a little bit on the domain where you're actually using this, because to my eyes, it almost sounds like it's performed because performance is cool and not it's performance because the users need that.
I like that. So I've actually avoided a lot of performance stuff, particularly for what you say. I don't want to do performance because it's fun or because it's cool, but because I wanted to, I actually want them to ask for it first. And so far, I haven't gotten too many requests in that way. For actual performance targets, it's not the engine, or I guess it's not the platform that I'm most afraid of, or even the processor, it's the user, because for them, summarizing a directory that has 250 files in it is just as easy as clicking an entire drive or an ISO image that has hundreds of thousands, millions of files in it. So I think eventually I'm gonna start getting those users that are like, oh, the thing is not working, and I'm like, it exceeds the design specifications. And at that point, I can start pushing against that ceiling that doesn't actually exist.
Okay, thank you.
Certainly, love that, thank you.
Okay, hello. First of all, thank you for combating human trafficking. Fuck human traffickers. Secondly, I'm curious about the social aspects of this, right? You mentioned a bit about these environments, right? And about how those complex requirements such as, literally you can't deliver updates in a traditional way. You have to go find the Igor guy who controls the deployments, having to rely only on the standard library. And I'm really curious, how did you have these conversations and who did you have them with in order to, explain to, I guess, customers, users, I don't know what a proper term would be, but to explain to the people, the stakeholders, hey, this is what Rust is, this is why you can trust this, there's not a string attached for me giving this away to free, especially since, these types of environments often have complex operating requirements in terms of adhering to security standards and et cetera.
Okay, I love that, thank you. Whenever I'm talking to stakeholders and I'm trying to convince them of something technical they might not understand, I really want to jump into what is memory safety, how does it work, why is it awesome? But usually I try to jump over that. I try to jump over that and think about who their boss is and who assumes the risk in that situation. So the things like the NIST brief and the White House brief, that kind of says that there's this other person who said that this is cool, so if this thing that I'm telling you about doesn't go wrong, then you'll be okay because these other people said it and you were just doing what they wanted you to do. And that seems to be a very strong sales way. Does that kind of answer your question there?
It does, thank you.
Yeah, pleasure. Thanks for asking. Out? Oh, okay, that's it. Thank you very much, everyone.